Hello everyone. This lesson we're going to talking about measuring power in three-phase system. There are two different ways or more than two different ways to measure three-phase power. Usually on the job you will see a three-phase wattmeter, a single wattmeter. You can measure all three-phase power. But in the class here we're going to discuss we're using 3 wattmeter or 2 wattmeter to measure the three-phase power. So the first one, we're going to use 3 wattmeter to measure three-phase power. We have a three-phase delta connected load down here. We connect 3 wattmeter. Each wattmeter connect on each of the lines. So we make sure the current going to go through the wattmeter before it reaches the load. And we wire up the wattmeter, the voltage coil, because we know each wattmeter, the voltage and the current have to have the same polarity. That's why I put a jumper down there. Then all 3 wattmeter gonna be in a Y connection for voltage measurement. Now, I could have balanced the load. If I have balanced the load, all 3 wattmeter gonna give me the same reading on there. But if I have unbalanced the load, 3 wattmeter might give me 3 different readings. For the total power, all you have to do is add 3 wattmeters reading together. So I have a wattmeter 1 reading a power, wattmeter 2 reading a different power, wattmeter 3 could measure also a total different number. Add those 3 numbers together, I have the total power for this 3-phase load. So this way is a very simple, easy way. I have 3 wattmeter. They all going to give me a reading. All those 3 readings will be the positive. So I add them together. That's the 3 wattmeter method. In the beginning of last century, there's a very smart scientist. He figured out for 3-phase power, we can use only 2 wattmeter. We still will be able to read 3-phase power. So here's the 2 wattmeter method. We have a 3-phase load. We connect 2 wattmeter each on one of the lines. The current for those lines gonna go through each of the wattmeter. Then the voltage coil, because we only have a 2 wattmeter, the voltage also for one of the wattmeter, the voltage coil to another terminal connect to the third line. Same for the second wattmeter, the voltage coil gonna connect onto another line. So in this way, this 2 wattmeter is gonna measure the line current. At the same time, we're gonna measure the line voltage. There's a complicated mathematical relation behind that, but for this one, the 2 wattmeter, we read total 3-phase power. The total power, still we will use the 2 wattmeter reading, try to add them up. But there is some kind of situation. Depends on the load, the power factor. This 2 wattmeter reading will be affected by the load's power factor. So I give you a table down here. The power factor of the load, if they are purely resistive load, our power factor is at 100%. For this case, the 2 wattmeter gonna give us equal amount of reading, and both those reading will be positive, and the total power will be just simply add those 2 wattmeter reading together. Will give us the total 3-phase power. If load, the power factor larger than 50%, but less than 100%, then one of the wattmeter will have a reading higher than another one. In this case, we don't know which one is higher, which one is lower, but the 1 wattmeter will read higher, but both wattmeter give us positive reading. Still, the total power gonna equal to that 2 wattmeter reading add up. If the load's power factor at exactly 50%, then 1 wattmeter will give you 0 reading. Another wattmeter can read the total power. When you do the calculation still, the total power equal to 2 watt-meter reading add up, even one of the watt-meter reads 0. The trick come here is when the power factor of the load is below 50%. Then one of the watt-meter gonna read positive number, but another watt-meter gonna read a negative number. If we are using analog watt-meter, the analog watt-meter, unless it's zero center, you will have a negative reading, but you can't read the value. So you have to reverse the leads for that watt-meter to make that negative read watt-meter to give you a positive number. You have to remember which watt-meter give you the negative reading. Because when you change the leads, now both watt-meter gonna give you a positive reading. If for this sample, the original watt-meter 1 reads positive, watt-meter 2 reads negative, you're gonna reverse the leads on watt-meter 2, but when you calculate the total power will be the watt-meter 1 reading, subtract watt-meter 2's reading. If watt-meter 1's reading negative, watt-meter 2's reading positive, you have to reverse the leads for watt-meter 1 to give you a positive reading. When you calculate total power, you're going to use watt-meter 2's reading, subtract watt-meter 1's reading. So here's how to use 2 watt-meter to measure the 3-phase power. You're going to use this in the AC machine, and you're going to use it in the motor controls. There's a formula to calculate based on when you only have 2 watt-meter, you have the watt-meter reading, you can calculate the power factor, but that's too deep for mathematical calculation. You don't have to know that. But when you encounter the power factor below 50%, that's usually when you're first starting a motor without a load, you will have those kind of situation, and you will have 1 watt-meter reads positive, another reads negative. Just remember, you have to subtract the 2 reading to give you the total power. If you have any question, you can connect us online or send us an email.